Today we're going to start working with special systems. These are systems of linear equations that may have a solution or may have infinitely many solutions. So one thing, this is example one from our textbook, example one. And this equation here I want to draw your attention to is in slope-intercept form. So we're going to look at one way that we could actually solve this system or figure out whether or not it has a solution is to compare the slopes. Now, right now we know that this is y equals mx plus b is slope-intercept form. And so in this case, let's just go ahead and look at this equation right here. And we have, let's take a look, b. So let's say my slope is m is 1 over 1, and our y-intercept is -1. And recall right here that this is our y-axis, and so our y-intercept is where this line right here is going to cross this axis right there. Okay? So that's what we're going to do. So when it's in slope-intercept form, as such as equation 1, really easy to graph. But now so we have this equation right here, the second one, and this is in standard form being ax plus by is the same as c. Okay. Well, we can actually rewrite this and put it into slope-intercept form. And the way we can do this is to, you guys probably already know this, is to add x to both sides. And then we rewrite our equation. And what I like to do is, when I rewrite an equation, I put the slope first. So y equals x, and then this here, since there's no minus sign, it's a positive 2. And we can look and pretend there is a coefficient of 1 over 1. So let's take a look at this. Now we're just going to compare the slopes of both equations. Of course, this one here, our slope is 1, and this one here, our slope is 1, and our y-intercept is 2. So if you look at this right here, we can actually graph the first equation, y equals x minus 1, or minus 1, pardon me. And so I'm going to put my dot, my first dot is at the -1, and then the slope is up 1 and over 1. And a -1 and negative, we can actually get a basic idea of what our slope is. Actually, we could do this a little differently. Get rid of that, and -1 and 1. There we have it. So that's kind of what it looks like, a straighter line. So we've graphed the first equation. And let's take a look at this. Get rid of some of this, clean it up a little bit for us. And here we have it, guys. Y equals 1x plus 2. So I'm going to go to my plus 2 where the y-intercept is, and then my slope is up 1 over 1. Up 1 over 1. And we'll just graph that. Of course, if my graph was perfect, you get the idea that we're looking at these two equations and we're seeing that they are parallel lines. There is no point that these lines will ever intersect. Therefore, we call this a system with no solution. There you have it. You may have also noticed that instead of just comparing the slopes by putting the two equations into slope-intercept form, you could actually use substitution here pretty easily. So I could actually substitute this in for the y in the second equation. So let's try that out. we're going to go ahead and see what happens. Minus x, and we're going to add plus x minus 1, and all that equals 2. Okay, so there we have it. That's the beginning, and now we're going to go ahead and simplify and combine our like terms. If I have a positive x, take away an x, that equals 0, minus 1, and that all equals 2. And if you look at this, this is a false statement, and as a result of that, there is no solution. We could of course graph that, but whenever you run into a false statement, so say you're solving by elimination or substitution, and you find out that the x or the y go away and all you have is two numbers on either side. If they're false, then there is again no solution. Okay, there we have that.